The 14.1 words per minute benchmark. Synchron's Stentrode just hit a median of 14.1 words per minute in the latest July 2026 comparative data, finally providing a concrete benchmark against more invasive competitors. This is not a thought reader. It is a 16-electrode array positioned within the superior sagittal sinus that maps motor intent to digital tokens without a single hole in the skull. As of this month, Synchron has reached a 100-patient milestone, providing the first large-scale look at the throughput limitations of endovascular brain-computer interfaces, and the hardware configuration explains why. The vessel wall filter effect. The core engineering constraint here is the blood vessel wall, which acts as a physical low-pass filter between the electrodes and the neurons. Unlike the 1024 electrodes on Neuralinks N1 that sit directly in tissue, Synchron's approach has to decode signals through a barrier that dampens high-frequency electrical spikes. To compensate, the 2026 software stack uses a transformer-based decoder to interpret broad neural burst patterns rather than individual spikes. This architecture is the primary reason for the speed gap observed in the command trial results, as it trades raw signal-to-noise ratio for a procedure that is essentially a routine catheterization. This hardware trade-off is now leading to a new class of LLM integration, navigating latent space directly. This bandwidth bottleneck is being mitigated by a shift from character-by-character typing to direct latent space navigation. By leveraging Apple's native BCI human interface device protocol, this Stentrode is now used to select entire tokens within language model prompt windows through Imagine gestures. However, even with the July 2026 firmware update, error rates for complex prompt structures remain 12% higher than traditional eye tracking systems. The current throughput sits at roughly 10 bits per second, which raises questions about whether this method can ever compete with physical inputs for high-precision coding or technical work. But for builders, the data suggests a deeper shift in how we might eventually prompt models. The signal under the noise. The transition from medical utility to a high-bandwidth prompt interface depends on moving past simple cursor control and toward direct latent space navigation. By referencing the signal dampening inherent in the endovascular approach and the shift toward token-based selection, it becomes clear that Synchron is optimizing for stability over raw word counts. For builders and researchers, the implication is that the future of prompting may not be natural language at all, but the manual manipulation of model vectors via motor imagery. This would effectively remove the physical fatigue of voice or typing, turning the motor cortex into a dedicated coprocessor for inference. While the bandwidth remains low compared to intracortical threads, the regulatory speed of the endovascular path makes this the most likely hardware for first-generation consumer adoption. Watch the upcoming August 2026 pivotal trial enrollment figures as the first indicator of whether this interface can move beyond clinical settings into sustained, daily use. Subscribe for more